Right now, 3,000 American troops are already positioned along the border with Iran. They are holding the line in a tense, dusty environment, waiting for heavy support to arrive. The infantry and Marines are on the ground, but they cannot fight a sustained campaign alone. Exposed troops are highly vulnerable in open desert combat. They rely on mechanized armor to absorb incoming attacks and deliver heavy return fire. To supply that armor, military bases deep inside the United States immediately shift into high gear. Rail yards on these installations begin loading hundreds of armored vehicles directly onto flatbed railcars, securing them with heavy chains and blocks to keep them from shifting during the long transit to the coast. Simultaneously, an air mobilization kicks off. At military airfields, Boeing AH-64 Apache attack helicopters are rolled out of their hangars. Crews unfold the rotor blades, lock them in place, and power up the aircraft so the Apaches can be flown directly to the port where naval transport ships are waiting. When these cross-country rail and air convoys converge at the coastal staging areas, the scale of the operation comes into full view. The port fills with rows of military hardware, stretching in every direction, including light fuel tankers, recovery vehicles, M2 Bradley fighting vehicles, and M1 Abrams main battle tanks that weigh over 70 tons each. Projecting global combat power requires physically picking up tens of thousands of tons of heavy machinery and transporting it intact across the planet. The specialized maritime vessels designed to carry this massive hardware are known as roll-on, roll-off, or ro-ro sealift ships. These vessels feature a large stern ramp that allows military vehicles to drive straight inside the ship's cargo decks under their own power. This diagram illustrates a ro-ro ship's empty cargo decks and its overall center of gravity. Vehicles are not driven aboard randomly. Every piece of equipment is mapped out in a strict mathematical framework known as a load plan, which dictates the exact parking spot based on weight, size, and the specific order it needs to be offloaded at the destination. The primary structural constraint in this plan is raw mass. The absolute heaviest assets, particularly the 70-ton Abrams tanks, must be directed down to the lowest decks. Here, the ship's internal steel structure is strong enough to handle the concentrated weight without buckling. To balance the physics of the vessel, the lighter equipment, like Humvees and mobile command posts, are routed higher up. This precise distribution keeps the entire ship's center of gravity stable in the water. Executing this load plan means navigating multi-ton machines through tight enclosed cargo decks. Drivers rely entirely on the ship's crews using hand signals and radios to park these vehicles mere inches apart, squeezing out every available square foot of capacity. The load plan cannot be improvised. A single miscalculated deck weight or a wrong turn that clips a 70-ton tank against a support column severely compromises the physical structure of the ship. Because the troops in the Middle East are waiting, the loading process is set to a brutal timeline. Crews work around the clock in a continuous 72-hour operation, shifting seamlessly from daylight pouring through the open ramps to the glare of overhead industrial lamps during the night shifts. To utilize the vessel's maximum spatial capacity, forklifts move through the staging columns, packing smaller containers of medical supplies, toolkits, and spare ammunition directly into the negative space between the parked vehicles. This diagram shows the massive physics problem of an ocean crossing. Once the Sealift ship is out on the open water, it experiences violent pitching and rolling, exerting severe force along the X, Y, and Z axes against these parked metal vehicles. To secure them, Army transport specialists and ship crews run heavy-gauge steel chains from tie-down points welded directly into the deck to the frame of every vehicle. Using a turnbuckle to pull the tension tight, they lock the front, rear, and both sides, neutralizing the chance of movement in any direction. Surviving the ocean transit requires extreme logistical discipline and physical restraints. With the heavy machinery locked down, the stern ramps seal, the mooring lines are cast off, and the fully loaded ships push into the shipping channel. Weeks later, the Sealift ships dock at a port in the Middle East. The equipment rolls down the ramps and immediately pushes toward the frontline border, where the American forces put it straight to work. Out in a forward position, a reconnaissance team unpacks a hard case and assembles a drone. They lock the wings and tail in place, verify the camera feed on a ground station, and then spin up the motor to launch the drone for a surveillance flight. The operators watch a live video feed, scanning the dry riverbeds and open ridgelines below to pinpoint exact coordinates for enemy vehicle staging areas. Those coordinates are sent directly to the payload delivery systems at the Sealift pipeline deployed. The M142 HIMARS is a highly mobile, six-wheeled truck carrying a single heavy rocket launcher pod, parked out of sight behind a low ridge. The fire order comes through. The first rocket ignites and launches out of the pod with a massive wave of flame, rocking the heavy truck. Seconds later, the second and third rockets launch, streaking into the sky toward an enemy staging area dozens of kilometers away. Each rocket carries a payload designed specifically to destroy armored vehicles in the open. When the final rocket leaves the pod, the crew lowers the launcher to its travel position, shifts into gear, and immediately evacuates the firing point to avoid counterfire. This explosive, frontline combat power is the final, visible fraction of a meticulously engineered global supply chain that moved heavy steel from domestic bases all the way to the battlefield.